Okay, in example 6, we're going to solve. This time we need to get tangent by itself. So let's move that 1 over. And let's get rid of that 3. And then remember to get rid of the square, we take the square root. And when we take the square root, we're going to get plus or minus the square root of the top over the square root of the bottom, which is plus or minus 1 over the square root of 3. Now, normally we say we don't want a radical on bottom, but this is not my final answer, okay, guys? So what we're looking at right now is that tangent of x is equal to plus or minus 1 over the square root of 3. Now, remember, tangent is y over x. So if we thought about this as an ordered pair, my y is going to have a 1 and my x is going to have a square root of 3. What do we have that looks similar to that on our unit circle? Well, we have the square root of 3 over 2 and we have a 1/2. And it comes to that when we try to solve this, or when we put, let me do this. When we put y over x from our ordered pair, those 2's are going to cancel when we do our keep it, change it, flip it, or we try to multiply by the little denominator to get rid of the fraction within a fraction. Either way, we'll end up with 1 over the square root of 3. Now, the only difference is, do I want this to be positive or negative for tangent? Well, again, just like in example 5, that plus or minus means I'm going to look for where tangent's positive, which is going to be in quadrants 1 and quadrants 3. And I'm going to look for where tangent's going to be in negative, which is in quadrant 2 and quadrant 4. So what it comes out to be is when you have that plus or minus, you're looking for an angle in each of the quadrants. Alright, so in quadrant 1, what angle has an x that is the square root of 3 over 2 and a y that is 1/2? Now remember, in quadrant 1, x and y are both positive, so I'm looking for them to both be positive numbers. And hopefully you're telling me that's going to be pi over 6. Now, when we go to do quadrant 2, because tangent's negative, let me just write that up here. So we were looking for the square root of 3 over 2 and 1/2. Now, we know in quadrant 2 the tangent's negative, which means one of those numbers has to be negative. And we know in quadrant 2 that our x is always negative. So I'm looking for this as my ordered pair. And hopefully you're telling me, well, that's at 5 pi over 6. Now, in quadrant 3, we know tangent's positive, but they both can't be positive numbers because in quadrant 3, we know x and y are both negative. So we're looking for the angle that has x and y both as negative that looks like that. And hopefully you're telling me that's a 7 pi over 6. And then in quadrant 4, we know that that y value needs to be negative. And so the angle that has that as an ordered pair would be 11 pi over 6. And so there are our 4 solutions for example 6.